Hello. So we're gonna start today to look into more about the pattern on the surface and how to intersect those patterns with the surface. Okay, and then we're gonna speak about different kind of patterns. So for now, we are gonna just focus on the grasshopper definition and yeah, how to develop it. And the patterns for the first exercise will be circles. Okay. Okay. So from last time, we had this boundary box that I said has nothing to do with grasshopper or anything. It's just a way for me to decide on the curves. And we did a loft between these two curves. So today we're gonna do this loft surface, and then we're gonna divide the surface, and then we're gonna create those patterns. So let me type grasshopper and see what we've got here. Need to open recent files. Not responding, just give it a second. Okay, so we're gonna create those patterns on the surface. And what we are gonna do, because the surface is complex and the patterns are very simple, there are plain patterns, we're gonna move them and extrude them and extrude the surface and intersect them. Okay. So I will take you step by step how we are gonna do that. So you can see the final result here in this one. So this is what we will be aiming to do, and you can see it has a thickness, and actually I can maybe I should I can bake that, but it will take a bit of time, so I'll do it after the session. But you can see the thickness of it. Okay, so that's what we are aiming to do here. So I'm just gonna do it in front of you, and what I'm gonna do, I'm gonna disable the view of this one. So basically, here is the definition. So we will add curve, multiple curves into this icon. We're gonna do loft, we're gonna divide it, and then we're gonna populate it with circles, and then we're gonna move it. Okay, and then we're gonna do extrusion for moving it, and for the extrusion for the circles and for the surface. And then what we are gonna do is something we worked on last time, which is the Boolean difference. So we're gonna do Boolean difference, but in a grasshopper. Okay. So let's start now with our definition. Okay, so I'm gonna start on a white Canva. I'm gonna type, so I need curve and I need loft. Okay, gonna zoom in so you can see. So now they are orange, they are warning because they say they don't have any parameters. So I'm gonna say curves, set multiple curves. So the idea of this one is not to manipulate the curves or change the curves, but rather to loft the curves to get a surface, basically. Okay. So this is as easy as this. So this is the loft operation, and it asks for section curves, and then here, if you hover over it, it says option, left options. Okay, so for now we don't have options. And then what we're gonna do, we need to divide this. So let's type divide and see if we can get that divide, divide to that command. So we need to divide a surface. So divide surface. You notice here it has an S. So we connect this one. You can always, if it's a new command for you, you can always hover over it and say what those initials standing for. So S for surface, surface to divide, which is the left surface. So now it populated it with U and V. As I said, in Rhino it's X and Y. We call it U and V, but we can't control how many here. And the whole reason we are using Grasshopper is to control as much as we can and do variations basically. So I'm gonna add those sliders. You can see you count the name. Then I'm gonna have V here, which is 10. So we can have it as big as we, as more points or less point. We can populate it in this way. And then what we are gonna do, we're gonna add the circle function. Okay. So we'll double click circle. Now, as you can see, there's so many options of circles. I'm gonna choose this one. So this circle is defined by center, and I already have the center, which are the points, and the normal, which is the normal of the surface, and the radius, something I can control. So what is the output of this component? Points, which is the center, and then normals. So the normals of the circles, we want them to match the normals of the loft. So you can see if I do Control Z, you can see how the, maybe let me add the radius first. So 0.5, I'm gonna put for now. I can make it a bit less as well, so you can see. So if we zoom here, talking about the normals, you can see how the circles are kind of flat. They are on the plane X and Y, and they are not adapting or mapping the loft surface. So if I connect the normals together, you can see immediately what happened. It adapt to the surface. So Control Z, and then notice, look at the Rhino screen. Look what happened. It mapped it. It mapped the surface. The circles are adapting and mapping actually the actual surface. So I'm gonna hide this curve. Don't need this curve at the moment. And what I'm gonna hide. So here, when your definition started growing, it's easier to start hiding things and keep a few things to appear. And now what we need to do is basically to move those circles. And the reason I want to move them is they really, I mean, even I told you they are mapping the surface, but not 100%, because the geometry of the surface is really complex. And this is just a simple circle. And at some points, I don't think they 100% map the lofted surface. So when we move them and extrude them, we will have that kind of real connection and real mapping of the surface. So for now, I'm gonna move. I'm gonna type the function move. And then here, this is geometry, base geometry. So our base geometry basically is the circles that we want to move. And then if we go to this one is the motion, so the vector. So previously we used Z, for example. So you can see them how they went on the Z direction. I can add this as well. And then you can see how that's kind of affecting the but really I don't want to move them only in the Z. I want to move them in all the directions so they adapt really to the surface. So what I'm gonna add is something called amplifier, amplitude, and this is a vector that kind of do the movement in all directions. So set the amplitude or length of a vector. So we don't have to worry if it's X, Y, or Z. And then, so it's giving me a warning because I need to give it some input. So the vector of it, I want it to be exactly like the vector of the points. I'm gonna put it here, and then so if I want to move them, basically I want to move those circles. So I wanted to have that direction from the surface and basically from those points. And this one is amplitude, so the length or value, so how much is the offset basically. So I'm just gonna put a slider. I'm gonna type 5, for example. I'm gonna do this and gonna make it a bit closer. Okay, let me turn those off because it's a bit now confusing. And actually those points as well. I'm a bit not happy with that because it's intersecting kind of the surface, and I don't think it should do that basically. So let me check. I mean, it might do that. Yeah. A second. My mouse got a bit stuck. So looking at this again, so I need actually to connect them with the normals of the surface of the divided. Yeah, now that looks better. And then here, I need to make this number a bit smaller. A bit rounded. Yeah. Maybe 0.5. So these are the ones I moved them. So just to recap, so we did the circles and their centers were exactly the point from dividing the surface. And the normals of those circles are exactly the normals from again, the points. I'm gonna show you the points. Those points are on the surface, and Grasshopper kind of gave us those points when we connected the surface to this function surface divide. So that's why it's very important that when we move those circles, when we move them, that when we use the vector function, the amplitude, that the vector or the direction of the vector is linked to those points, basically, to the normals or vectors of those points. Okay. So what we are gonna do next, we're gonna do extrude, basically. So first, I'm gonna extrude the surface, give it some thickness. So I'm gonna type extrude. Let me see what kind of functions I have. Just gonna use this one. This will do for now. So extrude, gonna say surface, and this one is the base. So it's saying this one for extruding curve or surface. In this case, we have a surface, and then here we have the basically the direction. So the direction, we need also to give it is a direction, basically, to extrude it. So I'm just kind of copying what I would do in Rhino in terms of extruding this. And I'm gonna give it a number 0.5, for example. I'm gonna put this here. You can see the thickness immediately. It's there. I'm gonna make it a bit thinner, and yeah, so I'm happy with this thickness. Okay. And then I want to extrude those circles that I moved them. Okay, so I extruded this surface. So I'm gonna turn this off actually, and turn those off. And then I'm gonna extrude those ones that I moved. So it's the same function. I'm just gonna say extrude. Then I'm gonna use the same extrude. Sorry, I'm gonna say circles here. And then the base would be the geometry of the circles. So you can see here, if I put my mouse on it, you can see how many circles I have. And then I'm gonna put it here. I'm connecting it, and then here the direction. Again, I'm gonna do similar to this one, so I might as well copy it. Amplitude. So Control C, Control V. And I'm gonna connect it with this one here. And it is, of course, connected with the dividing part. Yeah. Now it should be, maybe I need to give it more than this number. Should intersect with it. It's a bit difficult to see what's going on. Let me see if I can see in other views. Is it intersecting? No, it's not intersecting. So probably I need to make it minus actually. Let me go back to perpendicular, sorry, perspective. And here I'm gonna do -1 or minus, yeah, 1 for now. Let me see that. That looks better for me. You can see that it's intersecting. Let me check other views. me, yeah, here it's intersecting. Yeah, I'm happy with this. And now what we are gonna do now is the moment of truth. So remember how let me show you actually before we go back here. Remember, and basically we did the Boolean difference. So let me do another one here just to refresh your memories. So it's always good to move them here. Yeah, looks okay here. Let me check again. Yeah, so let's do the solid difference. So you can choose this one, enter, and then choose this object and then enter. This is what you got from it. Or you can say, I'm choosing this and then that one. And then this is what you're gonna get. So it's kind of similar thing we're gonna do here. Take it out. So here what I'm gonna do is I'm gonna go back to Grasshopper and I'm gonna type difference. Solid difference. Yeah, that's the one. And you can see the two shapes intersecting. That's the one I want. So you have A and B. So here the extrude surface. So this is at the end what comes down to. These two. I'm gonna put A here and B here. And it's gonna take some time to do it because it's heavy. Let me see what it did. Oh, I didn't notice I'm doing that. Okay. Let me disconnect. And let me go back to my circles radius. Yeah, maybe this is better. Okay, now let's go back again. Connect. And let me do this kind of trick. Usually this is for the information. It's flattened the data, so it just makes it a bit easier for Grasshopper to read all this information. So let's give it a second. So I'm gonna turn those two off. Actually, only this one off. So I can see it, but it's not similar to the other one I had before. Let's see, I need to turn this off. Yeah, now we got it. Okay, so when you run the difference, just make sure those are off so you can see the final result. And then we can, of course, bake it. I baked the green one, so Control Z. Sorry, so I need to select this one here, and then actually I'm gonna bake this one. I'm gonna put it on my favorite layer. Still working on it. It says undoing Grasshopper. Why? I'm doing bake. No, I think it's baking it. It's just taking some time. So I'm just waiting for the bake to finish. I think my machine is not that strong. I'll give it a go one more time and that's it. Okay, so we will look into this later, but I want to go back actually and just revise what we did. So it's really, really simple. So basically all we imported is those three curves, and then we did apply loft on them. We divided the surface into U and V. So also it's something that will affect the final result. So these are parameter. The radius of the circle. So I think the divisions and the circles need to be in proportion, so you don't have some circles intersecting. And then what we did, we moved them and we gave them this function amplitude, where the vector of the moving will follow the vector or the normals of the actual surface, lofted surface. Also, we can the distance, we can control it with this slide. And then what we did two operations of extrude. So we did one for the surface and one for the circles. And of course, we need direction and a number slider with it. And then we did the difference, solid difference or Boolean operation to get this final result. Okay, so this is how we get a simple pattern on a complex geometry. Now, if we want to do the opposite, okay, so let me copy those. Or actually, I want to copy only one of them. So let's say we have this, or I don't need to copy it. I'll just do it with you, so we do it together. Okay, so let's do now a simple surface, but a complex pattern, okay? So I'm gonna work here. I'm gonna work on a rectangle. I'm gonna give it add 50 by 50. I think I'm gonna do it. Yeah, and then I'm gonna, so all we need is a rectangle and a point. So this rectangle could be square, could be really anything, okay? It's really simple. We're gonna introduce different kind of patterns. So we're gonna do Voronoi, we're gonna do circles, we're gonna do polygons, we're gonna do different kind of things. And all we need is two inputs from Rhino, is the curve and the point. And then we need to populate it, to populate this area. So let's just start bit by bit. So I'm gonna type curve. And I'm gonna type point. Okay, so I'm gonna set this as one curve. Not sure it did it, set one curve. Yeah, now I know it did it because it's green. And then I'm gonna say set one point, gonna choose this point. So how do you know you have them selected? With this. And then I wanna populate. So remember when we had this complex surface and we did divide that surface here, we can't divide because it's an empty kind of, we don't have a surface, we have just the line of the rectangle, but we do have a contained area. So there is a way to divide it into points. And so we need to populate it. So I'm just going to write populate. So I'm going to populate in 2D, okay, because it's a 2D surface. And I'm going to look what input it needs. It needs the region, which means rectangle that defines the 2D region for point insertion. So here we have that rectangle that they are mentioning. So I'm going to give it to it. So you can see how it populated quickly. But again, here, when Grasshopper does it like in a default. So we can't kind of have control over how many points, unless there is an input where we can put a slider. So let's look here. This could be the numbers of the points. We can count number of points to add. So we can add slider. We can say, I don't know, 100 points, for example. So we have as much as we want points. Okay. And then here, what do we have? We have a seed, random seed for insertion, and points optional. So these are optional. So for now, we're gonna leave it like this. But what we can do, and it's interesting because I think Grasshopper inserted 100 points. Yeah, so what we are gonna do with this, we're gonna introduce to it a pattern called Voronoi. I don't know if you heard of it, but it has to do with physics, and it is inspired from nature, basically. So it's mimicking a system that already exists in nature. So what does this Voronoi needs? Okay, it needs a point. Okay, so we have points here. We're gonna connect it, and look what happened if I. So what it did, it created this big rectangle, and then this rectangle, like the Voronoi, is concentrated in the inside kind of rectangle that we created. Yeah. Yeah, so you can read a little bit about Voronoi. It's very interesting mathematical concept. And you can see it, as I said, in nature. So some people call it like it's a pattern that occur in nature, basically. So every point in a given region, so you have, like, you can see those shapes are kind of controlled and deducted by those points. So there's a mathematical logic for it. The distance between the points and how those polygonal shapes are basically created. So you can see those polygonal kind of regional things are created next to each other. So it's kind of tessellation, if you want. I don't know if you know this also concept of tessellation. Tessellation is breaking an area to a smaller kind of units. Yeah, so just look into the Voronoi. There's a lot of it, and it goes back to an old mathematician in the 17th century or something. So anyway, we go back to Grasshopper. So this is just a little background of Voronoi. And then what do we need? Radius. For now, we are fine. It's optional as well. And then boundary. Boundary is good because we need all these lines to come here. So I'm just gonna connect the boundary with the curve because I want it to be contained. Okay, so let me show you again what happened. So it's like that. And when I connect the boundary to the actual rectangle, it's all contained here. So that's what I want, basically. And then what we want is to have some kind of boundaries between those local regions, those polygons. So how do we do that? So basically what I'm saying, I need to offset this polygon so I have a thickness between them. So we can do that by using scale. So I'm gonna scale them down, basically, scale those for a noise. I'm gonna say scale, and then this is the scale I've got. I need to connect it to the geometry, and then I need a basically let me see, what is this letter? A center of it. Okay, so the center should be the those points. Those are the centers from where I want to scale. So anytime you want to scale, you need a center. We've done this in a previous session. We need also an amount. So here, kind of scaling factor. Here, Rhino already inserted this 0.5. Gonna insert similar, I think, 0.5 into a number slider and then connect it to the factor. But then I can make it smaller and bigger. And if I hide those two, actually, you can see how I can have this pattern. Now, let me put it here. So if I add it more than one, probably they will intersect. But then we have all these patterns that we can actually bake at the end. Okay. So we scaled those. What else? So why did we add this point? Maybe you are wondering, this initial point. This initial point is, we're going to deal with it as an attractor, meaning an algorithmic modeling. It's kind of built on having the ability to scale things and to have some effects, basically. So I'm going to show you here the attractor effect. And for that, we're going to do a relationship between those points. Those points and this point. So we need a relationship between them. So to do a relationship between them, we need to measure the distance between them, basically. This is the one thing that comes to mind. So we have A, which is those points, and we have B, which is this point. And then what do we have? We kind of need to, now that we have this information, the distance between the center of each polygon with this attractor here. So now I'm moving it, nothing is happening because I need to do something with this distance. So maybe I do an addition, or maybe I do a multiplication. So I need to do something so the point that is closer to it will have a certain mathematical equation, basically. So let's say I'm going to do multiplication. Okay, and I'm going to multiply this distance by a slider number. And this would be really a small number. I'm going to try with that. Okay. But then instead of having this factor here, I'm going to have this new factor. So you can see the difference immediately. So Control Z, you can see how this is fine, regular. I'm changing the scale. It's all kind of getting bigger and smaller, not affected by this point that I have, which is here. While if the factor of the scale is connected to the multiplication, and then I start moving this point around, you can see it depends where this point is, the size of those polygon basically get bigger or smaller. So I can even make this number bigger or smaller. You can see how this is affecting the further away ones. So let's say I want to put it in the middle. See this effect. Gonna turn this off. You can see how this is affecting that pattern. So this is what we call a tractor, and this is how we do a complex geometry or a complex pattern on a simple surface. Now you can have this point out, but the effect will be like it will be different than if you have it inside, basically completely different. And then you can experiment and then choose the scenario that you want according to your design and why you need to have why you have chosen this possibility, for example. Okay, so the other thing that we can do is basically copying this definition that we created now. So we have the curve. So all you needed is 2 inputs and the rest was created in a grasshopper. So what we need now to do is copy this rectangle and copy this point. So I'm gonna copy them and then try with another pattern. But what I wanted to say as well here, for example, if I take these 2 points and I move them, you can see how it's also affecting the pattern. So you can also change the boundary box. So this boundary box could be changed. You can also do that. So you can have multiple really scenarios. I'm just going to bring it back to this one. And now I'm here. I'm going to copy this. Control C, Control V, and then I'm going to move it. I'm going to move the definition. Now what I need to do is set up the new curve, which is this one. And it will be a mess because it's still connected to the point which is here basically. And now I'm gonna say set 1 point. I'm gonna choose this one, and now we have this. So instead of Verneuil, we're gonna try and to add circles instead. So I'm gonna type circles. I'm gonna use this circle, and I'm gonna delete this one. Okay, I'm gonna connect it here. So the centers of the circles will be those points, and then the radius, I need to add the radius. So let's say 0.5. And I can make this bigger. Okay, so remember it's still not selected to the scaling one. So I'm just gonna do that. I'm gonna connect the geometry of the scale here, and you can see those, but we need only the scaling really. So I'm gonna turn those off, and I'm gonna make the radius bigger. So I'm gonna make it, I don't know, until 10. Yeah, now you can see the difference. So this is what you've got. And now if I move this again, you will have a different scenarios. Okay. And again, you can change the boundary. If I take ortho off, put this here, just do that, for example. Yeah. Let's copy it one more time. Control Z. I'm just going to do Control Z. I'm going to copy this and the point one more time. Control. I'm going to just type copy actually, because I like to click in Rhino when I want to copy. I'm just going to drag them closer to each other. So I need to have my worksheet tidy up as much as possible. So let's copy this definition again. So Control C, Control V, drag it down, and then I need to do a new setup. So I'm going to set up the point first. I'm going to say set one point. I'm going to choose this one, mess up that one, and then I'm going to say set one curve, which is this one. And now I'm going to delete this. I'm going to type polygon. Oh, not in Rhino. Double clicking here, polygon. This one sounds like it. Okay. And yeah, we need to kind of do the same. Let's look at this. So here is the polygon has a base plane, which is the curve actually. And then I think this is the radius. Just check. Radius. And then here we need to scale the geometry of the polygon. I think I should connect it here. Yeah. So I should connect here the polygon base plane with these points. I think I have them too big. There's something that I need to turn off, which is the polygon themselves, probably. Yeah. And then you can see here the size is changing. Okay, let's see what segments. Okay, this is interesting. So let's put 5. So you can see the polygon change. It could be a square, could be a triangle, cannot be less than 2 probably. So we can, the segment could go from 3 till 10, for example. Let's try that. If I zoom in. So also the polygon is giving you different kind of patterns. So even you can do rectangle if you want, for example. So there you go. You can see how it's affecting the density of the pattern. So I have 3 kind of simple surfaces with complex geometry using simple definition and using the attractor concept. Okay. Thank you so much.